Heat transfer is all around us, influencing everything from our morning coffee to the warmth of the sun on our skin. But how does heat actually move from one place to another? In this video, we will break down the three main methods of heat transfer: conduction, convection, and radiation, using plenty of real-world examples. First, let us talk about conduction. Imagine stirring a hot cup of soup with a metal spoon. Notice how the handle of the spoon quickly gets warm. That is conduction in action. Conduction happens when heat is transferred through direct contact. In this case, the hot soup heats up the metal spoon, causing the particles in the spoon to vibrate more vigorously. These vibrations spread from one particle to the next, transferring heat along the spoon to our hand. When we iron our clothes, the heat from the iron is conducted directly into the fabric, smoothing out those wrinkles. The better the conductor, like metal, the faster the heat will spread. This is why cooking pots are often made of metal, which efficiently transfers heat to our food. Next, let us understand what is convection. Convection is the up and down movement of a fluid, such as air or water, due to differences in temperature. A perfect example of convection is a pot of water boiling on the stove. As the water at the bottom of the pot heats up, it becomes less dense and rises to the surface. Cooler water from the top then sinks down to replace it. This creates a continuous cycle called a convection current, which evenly distributes heat throughout the water. We can also see convection at work in our homes with heaters. The warm air from the heater rises while cooler air sinks, creating a circulation that helps to evenly warm the room. Even weather patterns like sea breezes are caused by convection currents in the atmosphere. Finally, let us understand radiation. Radiation occurs through electromagnetic waves. Radiation does not need any material medium and can take place in space or vacuum. This is how heat and light from sun reaches Earth, traveling across the vacuum of space. When we stand in the sunlight, we feel its warmth because these waves are transferring energy directly to us. Even our microwave at home uses radiation to cook food. It emits microwaves that cause water molecules in our food to vibrate, heating it up. Infrared heaters, the warmth from the laptops, and even the light bulbs in our rooms all rely on radiation to transfer heat. Let us now understand the difference between all three modes of heat transfer through an example. When heating a pot of water, conduction, convection, and radiation all play a role in transferring heat. Initially, the heat from the stove travels from the bottom of the pot, through the walls, and up to the handle via conduction. In conduction, energy is transferred through direct contact. The saucepan then conducts heat to the water via conduction. The molecules in the saucepan vibrate and transfer heat to the water molecules they touch. The water heats up and expands, becoming less dense. the hot water rises to the top in the convection process and pushes the cold water to the bottom, where it's heated. This process continues till the water boils and circulates in the pot. In convection, energy is transferred through the up and down movement of a fluid, such as air or water, due to differences in temperature. We feel the heat of the flame when we stand near it, as heat moves through space as energy waves via radiation. In radiation, energy is transferred through electromagnetic waves. When the pan is removed from the heat, it loses heat to the surrounding air, again through radiation. To understand the exact difference between convection and radiation, let us take the example of bonfire. The thermal radiation from the fire spreads out in all directions and is able to reach us. This thermal radiation is mostly in the form of infrared waves and visible light. In contrast, the campfire heat transferred via convection shoots straight up into the sky and never reaches us. So, to sum it up, conduction transfers heat through direct contact. Convection moves heat in fluids through currents. And radiation sends heat through electromagnetic waves. Understanding these processes not only explains how heat moves, but also helps us better design everything from buildings to kitchen appliances. Thanks for watching. If you enjoyed learning about heat transfer, be sure to like this video and subscribe for more science content. Keep exploring the world around you.